Hi everybody, it's Mrs. Mancuso, Merm here to help you out with acids and bases. Last time I saw you in person, we were doing acids and bases and I was rushing right through it, trying to get as much done in a single day, hoping that we weren't going to come to this, but here we are. So I just wanted to go over acids and bases a little bit more. You'll notice this week I left you 3 different videos. So this is video 1 of 3. All of this stuff should be review, and I do have a lot on Schoology that you can use to help you understand it if there's something you're not sure about. And then when we have our Zoom session on Friday, you can also ask me any questions. So make sure you have a nice little sheet of paper where you can write down things that you're not sure of that you want to ask me when we're together. All right, so first of all, if we're talking about acids, acids are proton donors. So a proton is a hydrogen. It's just one positive. It has one proton. It has no neutrons. It has no electrons. So it's a proton donor, an H+. So if you look here at table K, look at all these acids. HCl, it's going to give away the H. HNO2, it's going to give away the H. Almost every single one starts with an H, and that's because as soon as you put it in water, like HCl, it's going to separate into an H positive and a Cl minus. Well, the H positive means it's giving away H pluses. The more H pluses there are in a solution, the more acidic it is. The more acidic it is, the lower the pH is going to be. All right, then we have our bases, and there's 2 kinds of bases. So Arrhenius was really like the first guy to come up with this definition. So for Arrhenius acids, it's always a proton donor or an H+ donor. An Arrhenius base is a metal plus an OH minus, which we call hydroxide. So if you're an Arrhenius base, you're like these first 3. Na is a metal with an OH. K is a metal with an OH. Calcium is a metal with an OH. And so these are OH minus donors. And so if you put NaOH in water, you'd get Na plus and OH minus. So because they're adding to the amount of OHs in a solution, that's why they are a base. And they're making the pH go higher. The higher and higher the pH is, the more OH minus concentration there is. Now this last one is what we call a Bronsted-Lowry base. And what it does is it does not donate OH minus. It accepts or picks up H plus from a solution. So NH3, give it an H plus in a solution. So let's say you have a solution and there was an acid and the acid put in the H plus. A base would take the H plus away and bring it into its substance. So it would be NH4 positive. So it would form that compound and it would take the H away. If you take away H's, you're actually going to bring the pH up, which is what a base does. So that's why there's 2 different definitions of a base. All right, my next screen is just to go over the pH scale. So way down here on the acid side, this is where the most H pluses are. And over here on the base side, this is where the most hydroxides are. And in the middle, the H plus concentration is equal to the OH minus concentration. So if you add an acid to something, it is going to get a lower and lower number. Or if you add a base to something, you're going to have a higher or higher pH. Higher or higher. So other thing I want to talk about with this scale, each time you move, so let's say I'm going from 7, a pH of 7 to a pH of 5. I'm going 2 places, so 10 times 10 is 100 times more H plus ions at a pH of 5 than there is a pH of 7. So each step on the scale, as you go down, you will have 10 times more H pluses. So I think an easy way of doing that, let's say I'm going from 7 down to 3. That's 10 times 10 times 10 times 10. That's 4 zeros. So I think it's easiest to write my 1 and then add the 4 zeros. 1, 2, 3, 4. So it would be a pH of 3 would have 10,000 times more H pluses in its solution than a pH of 7. All right. And the last thing that I wanted to go over is how to use Table M. I definitely noticed when you guys did your acid-base extra credit lab that some of your answers to this weren't right. So I want to go over how to do it. So let's look at methyl orange first. So methyl orange, if I have a solution, and here's my solution right here, and my solution is yellow. If it is yellow, that is telling me the pH of this solution is 4.4 or higher. All right, so my solution, I added methyl orange to it and it turned yellow. So the pH has to be that second number or higher to be the second color. All right, let me give you another example. Let me just erase this quickly. All right, let's say I have a solution and I add litmus to it. When I add litmus to it, if it comes out purple, so here it is purple. Purple is telling me that it's between these two numbers because if it was red, it'd be 4.5 or lower. If it was blue, it'd be 8.3 or higher, but it's in the middle. So the pH of this is between 4.5 and 8.3, somewhere in the middle there. So what I could do is I could test it with another indicator. So let's say I add this Bromkressel green to it. And now my solution, okay, so I took a separate one of the solution. I don't keep adding it to the same one that's already purple. I start with my solution all over again that I already tested with litmus. And now I take a new batch of it and add Bromkressel green. And let's say it comes out blue. If it comes out blue, then that is telling me that it has to be 5.4 or higher. So I just narrowed down my range. Now I know it's between 5.4 and 8.3. I know it's not 4.5 because it wouldn't have turned blue using Bromkressel blue. All right, so it's just a way of using indicators to tell you what the pH is. All right, that's the end of the first video, just going through all the basics. There's a practice sheet for you to do on Schoology.